Nick, thanks very much. And Arthur, thanks very much for the chance to present. So I'm going to try and talk very simply and very quickly in the minutes remaining just about, we're talking about process innovations for reducing footprint at mining operations, although ironically the process technologies I'm going to talk about are actually mining technologies. One of my specializations is mine mill integration, and one of the technologies that I was very fortunate to be involved in the development of was bulk sorting technology using X-ray fluorescence in the mine. And the flagship technology for that is a system called shovel sense, where high speed, can I use it? Okay, I don't have a pointer. In the picture on the right, you can see a shovel with X-ray fluorescence sensors integrated into the bucket of the shovel. So they're fast, they're long range, and they're robust, and they take measurements of the grade of the material loaded in the shovel as it's loaded into the shovel. So what you get is a direct measurement of the specifically base metals, so copper, nickel, iron, cobalt, as the material is loaded into the shovel. So by integrating the sensing technology with the shovel, you turn a piece of loading technology into a piece of process technology. And it also integrates, as a technology, integrates very well with normal mine control systems, so fleet management systems, grade control, ore control systems, such that that instantaneous reading of grade in the shovel is then instantly compared to the expected grade of the material for that bench or stope, so that essentially a real-time cut-off grade determination can be made when the shovel's, for instance, working in ore. The mine plan might say that the material loaded in the mine is ore, but the shovel might say that it's waste, so we have the opportunity to then reject waste directly in the mining operation in the pit. Conversely, and this is actually where the majority of the value gets created, when shovels are operating in waste benches, or if it's an LHD working in a stope underground, the mine plan might say that that material is waste, but the sensors might actually say, well, hang on, this material is above cut-off grade because the mine plan isn't that good. 25-meter drill spacing or 50-meter drill spacing. The block model might have missed the fact that there's a seam of ore in the middle of the waste block. So the shovel has the opportunity to then recover relatively high grade, so above cut-off grade ore material from material that would have been classified or was classified as waste, and that creates a massive amount of value for mining operations. It works particularly well in base metals, nickel, copper, chrome, iron, zinc are the major applications. You can do precious metals essentially by proxy. So if you've got a copper proxy for gold, you could sense and sort gold in real time too. Platinum also has some very good proxies. So very effective technology for improving the value at mine sites. So I'm given the time signal, so I'm going to skip very quickly. So two studies that we've done more recently with this kind of technology is for Ferrexpo at their northern deposits, where Ferrexpo is contemplating a open pit to underground transition. And iron ore's, it's pretty challenging taking iron ore operations underground, so we need to get innovative about managing grade, for instance, and getting the best quality material to go to surface at the lowest possible cost. And this is a very impactful technology in that regard. And then the second example, which is touching on what Nick talked about earlier, is in ferronickel, where again it's such an energy intensive flow sheet. You're going directly from mining typically into a pyrometallurgical flow sheet, or directly from mining into a hydrometallurgical flow sheet, and very, very small changes in grade of either the primary metal, the nickel in nickel cases, or chrome in chrome cases, but then simultaneously a reduction in the iron content can make massive changes to the overall value of what's created, because you're producing more primary metal nickel in this example at lower cost. So modern projects do face many challenges, geopolitical challenges in the case of for Expo at the moment, and we're hoping that that ceases so that we can continue doing good work with our client there. Sometimes it's mineralogy, grades are getting lower, mines with good deposits are getting deeper, and energy's either scarce or very, very expensive, so we have to get innovative about the way that we mine and extract and beneficiate these commodities to be continue to be successful in our business. Thank you.